root of 2 plus the square root of 2 over 2. 30 was the square root of 2 plus root 3 over 2. 31 is 1 minus the square root of 2. And 32 is the square root of 2 minus square root of 3 over 2. 32 was square root of 2 plus root.
We did what number now? 29?
32. It was 2 minus the square root of 3 all over 2. Yep, I can do 31.
Thank you so much.
Let's see if I can do this correctly.
So, the square root of 2 plus, it's 2 plus square root of 3.
Alright, so we have the tangent. Alright, tangent. 157.5. Alright, here we go. So, this is still a half angle. So I've got so this is theta over 2. Ooh, that's bad. So to find out what theta equals, I set up my equation 157.5 equals theta divided by 2. So how do I get theta by itself? There we go, multiply by 2. So my theta is going to equal 315. 315. So from here, I'm going to use the formula. Tangents of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Remember, this is going to tell us whether this is positive or negative. This is the angle we're actually going to use to plug in for cosine of theta over sine or whatever. Both cosine thetas. So, where is 157.5 located? Which quadrant? Second. So, because it's in the second, is tangent positive or negative in the second quadrant? Negative, so I'm going to have negative square root Then from here, I'm going to have 1 minus and then 1 plus. Now I'm actually going to use this to find my cosine. So what is the cosine of 315? Root 2 over 2. Positive root 2 over 2. So I have root 2 over 2. Root 2 over 2. So I have negative square root. I can say that's 2 over 2 minus square root 2 over 2. Over 2 root 2 minus, or sorry, plus root 2 over 2. Found the common denominator, just made the 1 equal to 2 over 2. Then, I can do 2 minus root 2 all over 2 over 2 plus root 2 all over 2. What can I do now? Keep, change, flip. So 2 minus the square root of 2 over 2 times 2 over 2 plus root 2. Twos cancel. So yes, we're going to have to FOIL here in a second. So I'm going to have negative square root 2 minus root 2 over 2 plus root 2. So we multiply by what? Conjugate, what's the conjugate? 2 minus the square root of 2. So negative square root. Top, I'm going to have 2. No, I'm not. 4. 2 times 2 is 4. 2 times negative root 2 is negative 2 root 2. Same thing here. Minus 2 square root of 2 plus the square root of 4. And on the bottom, this one, says the negative times negative. Then on the bottom, now here's the trick. Remember, it's like when we were foiling binomials way back whenever that was. The 2 middle terms are going to cancel, right? So all I got to do is multiply them. All I've got to do is the f and the L, because the 2 middle terms cancel. I'm just left with the first and the last. So I'm going to do 2 times 2 is 4. I'm going to do positive root 2 times negative root 2 to get negative square root 4. So then I'll have 4 minus 4 square roots of 2 plus 2 all over 4 minus 2. Simplify the top. Be 6 minus 4 root 2 over 2. Which then simplifies the negative square root of 3 minus 2 root 2. I divided 6, the 4, and the 2 by 2. Questions? Aubrey. All right. So we're gonna have a quiz. All right. I hate this word, but we're having a quest on Tuesday. So you'll see a little bit of everything we've done the last week, plus today and tomorrow. I will give you a study guide to review, well, so you can have it to review over the weekend if you want to, but we're also going to go over it. You can ask questions, whatever, on Monday. Tuesday. That's a math day, right?
Yeah.
Okay.
Yes.
That's what I thought. Wanted to make sure. Now, normally, I don't like this to be the first test I give because normally I do not allow this, period. But I'm giving you a note card. I will give you a note card tomorrow. You can put whatever you want to on it, front and back, for this thing on Tuesday. This will not happen again. It's just because this section, this unit, is probably the most, well, formula heavy, diagram heavy that there is. Bring this sheet. It does not have to go on your note card. If you forget it, I may put it on the screen. But that just, the unit circle is not included on your note card. Note card is just sum and difference, half, double, stuff we're doing today, stuff we're doing tomorrow, whatever you want to put on there. I would put the formulas on there.
How much is this question?
I haven't figured that out yet. Probably 50 points. I'm trying to make my tests usually out of close to 100. Quizzes anywhere from 20 to 40. This will be somewhere between that.
Points?
Yes.
How many questions do we have?
10-ish. 5 points apiece. No multiple choice.
No one?
No.
Golly, dude. Just count me out. What are you doing?
Well, if I gave you multiple choice, then it's all or nothing.
I'll take note for it.
If it's fill in the blank or free response, I can give you partial credit.
Tamara?
Yeah, note card.
Hey, Tamara.
Note card. Note card and.
All right, am I good to get rid of this?
I know.
All right. today, we've got a lot to get through today.
We have plenty of time. Oh, God.
Sadly, I'm not so sure because there's a back. So, we were able to get about 20 minutes worth of homework in the last class. So let's try to do the same. I'll check the homework from yesterday or whenever we had class again.
Is the, where's that sheet? Is it over there?
Yes, Kelly.
Yeah, here will come. Oh, it's coming.
All right. I got it. Now it's kind of warm. All right. So, today we're doing trig equations. Trig equations obviously stem from what we did yesterday and the day before. But today, instead of being given the angle and saying, the question saying, well, I want you to find the sine of 2 pi over 3. We're given the trig value and we want to find the angle or angles that it corresponds with. So, if we just kind of trying to get a general grasp of what's going on. We've seen these graphs before, correct? Maybe a while ago, but they look familiar.
Yeah.
We're getting about half a yes.
Yes.
Yeah, that was not a yes or no question. It's a you should remember this question.
Yeah, we've seen that.
So you've seen these before. The sine and cosine function, they have this curvy, wavy, up and down, repeating all the time. Tangent, over here it looks a little different. Now, our question will ask, what angle, so sine of theta equals 1/2. So if we look at this little snippet of our sine graph, it says, first of all, well, between 0 and 2 pi, how many answers are we going to have? So between 0 and 2 pi, how many answers are we going to have where the sine of 1/2 or sine of theta equals 1/2? And unfortunately today we're talking all in radians, no degrees today. So we're, again, what radians have a sine value of 1/2 between 0 and 2 pi? So where's our graph intersect? So our graph intersects once here, once there. Correct? So we're going to have two answers between 0 and 2 pi. So using the unit circle, what are those two angles? All right, so the sine of what angle equals 1/2? So on your unit circle chart, we're solely looking for the sine of 1/2, and then I'm going up to what angle that is? 30. In radians, it is what? Pi over 6. So the first answer is pi over 6. But we know there's two of them. Well, what other quadrant is sine positive in? Second. Which angle is the second quadrant is related to pi over 6? 5 pi over 6. So here are our two answers to this question. So sine of pi over 6 equals 1/2. Sine of 5 pi over 6 equals 1/2. Good with that? But now, what's special about these trig graphs compared to like y equals x? Well, they're in radians, yep. But what about the nature of them? Like, what does the graph keep doing? Well, it goes on forever, but it keeps this same pattern. Like it starts at 0, goes up and hits 1, curves and comes back and hits 0, goes past it, curves, and it just keeps hitting the same values over and over, right? Well, if that's the case, just like the unit circle, we can keep going around the unit circle. There's going to be more than just these two angles that have a sine of 1/2 if we extend that out to forever, right? So when it says between negative infinity and infinity, we have to think about, well, what's the period of one of these graphs? Do you remember what that term means? All right, the period of a trig function is how long, or what the distance is until the graph repeats itself. So it's actually, in this case, 2 pi. If I start at 0, 0. I go up, come down, get back to 0, and then I do the same. I hit the same y values again, in the same kind of spacing. So they have a period of 2 pi. So to find our general solution, our generic form, I'm going to add 2k pi to each answer. And what the k is just a constant. The k is talking about how many times I'm repeating it. So if I have my unit circle down here, and I have pi over 6, all right? Well, if I have pi over 6 plus 2k pi, well, if I plug 0 in for that means I'm at this point and I make 0 revolutions, right? I go around the circle 0 times. Yes?
Correct.
If k is 0, I'm still there. Well, if I say I add 1, if I put 1 in for this, that means I'm making 1 full revolution around the unit circle, and I'm ending back up here. But in all reality, instead of that being pi over 6, it's going to be 13 pi over 6. Right? I add 2 pi to this. That's 1 full circle. 13 pi over 6. Does this value still have a sine value of 1/2? Does this angle have a sine value of 1/2? Yes, it does. And I can keep doing this. I can go around again. So 1, 2. I could add 4 pi to it and give me another angle. And I can keep doing this forever. So that's why the generic solution, we add this 2k pi, with k being the number of times I'm going around the unit circle. And so I would do it for the other one as well. I would also do it for 5 pi over 6 plus 2k pi. That's sine and cosine. Both of them act the same way. Both of them will have, with the exception of one type that you'll see, two angles within 0 and 2 pi. And then you add 2k pi to both of them. For tangent. Tangent's going to work the same way, except the function itself is slightly different. So again, tangent of theta equals -1. So I'm looking from 0 to pi. And I want to see where my graph crosses at -1. How many times?
Where's -1?
The It's this big line right here.
2.
Twice. Here. And here. What angles are those? Anybody? Mm-hmm. -1. So where on our chart, tangent of what equals 1?
Oh.
45. So I'm going to have, all right now, power 4, but it's negative. So I'm going to be in the second or fourth quadrant, right? So if I'm in the second quadrant, what angle is power 4? 3 power 4. Now, if we do the exact same thing that we did over here with the period of sine and cosine, how many times does the tangent function repeat within this interval? From 0 to 2 pi, how many times does it repeat? Twice. So because it repeats twice in the span of 2 pi, its period is just pi. If I start at 0, 0 again, I'm looking to see how long it takes for me to get back to 0. So I'm going to go up this way, and then it comes way up there and comes back down here. And then I hit that point. The distance from where I started to where I hit that exact same point again and start the pattern over is 1 pi. So that interval, and then it starts over. And so then, this will be k pi. Again, same thinking, how many times am I repeating this pattern? And so this will be 3 pi over 4 plus k pi. Now I forgot something. What's the other one? Isn't there another tangent value or angle where the tangent value equals -1? Which one is that? 7 pi over 4. But I don't need to write 7 pi over 4 plus k pi. Why do you think that's the case? Alright, think about it. So, I've got my unit circle, bless you. 3 pi over 4 is here. 7 pi over 4 is down here. You don't have to write this, we're just kind of thinking through. If we were talking about sine and cosine, I have to put both answers because the period is 2 pi. So if I start at 3 pi over 4, if I go 2 pi, I go all the way around and come back there. So does it...
Will Caldwell, come to the checkout office, please. Will Caldwell.
So it doesn't hit this point here, does it? It skips this point and comes back here. So that's why we have to have 2 for this, because one of them skips the other one every time. For tangent, what is our period? Pi. So if I go 1 pi, it stops there, doesn't it?
Yeah.
So the formula in itself takes care of the other value. Because you have to go twice, and it stops. So whereas sine and cosine skip that other value. Tangent hits it just by the way that it is created. Okay? That'll be nice later on.
Later.
Hmm?
There's more? To this
Well,
problem?
no, we're done.
Okay.
This was like setting everything up, trying to get the brain thinking. Alright. Are we good with this? As good as we can be right now. Alright, so let's look at yes, number one. We want to solve each equation and give the general form. So our answers will have the 2k pi. Danielle, what angle has a sine value of the square root of 3 over 2? Danielle. Sine of what angle is root 3 over 2? Use the unit circle.
I don't. My head hurts. I've been sleeping all day.
Hopefully everything's all right. Somebody help her out. 60. So, pi over 3. Again, pi over 3. Where else is sine positive?
The second quadrant.
Second quadrant. So, I'm going to have, like you said, pi over 3. What are you going to do with pi over 3? It's a general form. Pi over 3, then
5 pi over 6.
alright, 5, no, not 5 pi over 6. 2 pi over 3.
Oh, I was.
But what am I adding to each of these because it says general form? General form. What?
2k pi whatever.
Plus 2k pi.
So I need to hit some. Then what you say, Eli? Yes.
Because it wants every single possible angle. Alright? Every single possible angle.